Hello everyone, I'm Dominic Jakob and welcome back to my channel. Today I will present a computer networking project, a fundamental topic in the career of a cybersecurity specialist. As you are already used to, I prepared the presentation and afterwards when we pass to solving the actual task, I will showcase the basic project and afterwards the conclusion. The presentation, PowerPoint presentation, it's in Romanian and my speech will be in English. So let's get started. Now, it is a similar project as the one from the Cybersecurity Masterclass. However, in this one we will focus only on computer networking and we have several tasks that were solved. So in the first chapter I will present them, then how I solved them, afterwards the conclusions that I find out from the task. Basically this project encompasses the knowledge that I acquired during my study in computer networking. It allows an appropriate level of knowledge that can be built upon for a cybersecurity career, and I find computer networking essential basically in this on this path. Now, the medium on which I worked was in Genesis software, and the tasks were structured into two parts: routing, showcasing this topology, we will discuss later the task, and the second one was switching. Okay, this is the second typology. Now, let's get started with the actual task. So for the routing part, it was needed to subnet basically, so to allocate IP addresses for the routers on this typology. Okay, so this network was 89.61.1.128.0 with a mask of /24, and I needed to allocate networks here, and also on the serial interfaces, such that I divide them into smaller networks. After that, a task was to use static routes between the routers. However, I opted for dynamic routing using OSPF protocol. I used a static route from R4 router to ISP router, which was a default one. So basically this ISP router should be connected to the internet, you will see later. Okay. Also, a virtual machine should be integrated. I chose a WordPress by Bitnami, which is here, this server, and the entire topology should be connected to the network of the host, okay, the Windows in my case. Now, in terms of switching, in this typology you see two routers. This is one part, this is the second part. On all switches, 6 VLANs should be created for marketing, for sales, for production, for financial, for human resources, and for IT. Then the interfaces between the switches should be trunk, and also these ones, and the interfaces between the switches and the end devices, in this case the PCs, should be access. Okay, router on a stick, protocol should be configured such that access between the PCs, between the VLANs, is obtained, and static routes between these two routers should be configured such that you can go from one part to the other. Okay, I opted to solve the task and integrate it in one typology in Genesis 3. Basically, the routing zone, it's this one together with this machine, and I implemented additional an additional virtual machine on Ubuntu 1, and the connection to the internet it's through this cloud, which is basically connected to my host. Okay, this is how I connected the topology to the LAN of the router. And this part, which is area 1 and area 2, it's the switching part, and these are the one from the left and one from the right. That's why I chose also these colors with yellow and green. Now, in terms of solving the task, here I used area 0 for OSPF protocol, indeed. I use multi-area for OSPF, so basically we have also area 3 and area 4 for this network, such that the routes are known by all these routers. However, area 1 and area 2 are just designated with the name, such that I can understand from the switching path, so they are not integrated like that. Okay. Now, in terms of solving the actual task, I think it's better to describe them straightforward in GNS3, and also a bit the intro part of configuring this basically technology such that everything works, because it's not that simple. Okay. Now, starting in GNS3. So we have this topology. First of all, in order to implement switching and routing in such a way that they support virtualization, I needed to use GNS3 IO machine. So basically some images, some basic virtual images representing physical router and switches were inserted in GNS3 and implemented in this topology. In this case, all these switches basically do actual switching. By default, this is not possible in GNS3. Also, this router, the ISP router, again, it's a router that allows virtualization. So basically, it allows this and also the connection with this one. Okay. Now, in terms of how are connected these two virtual machines, I installed them in a virtual box, Ubuntu 22 and WordPress 6.632. And in terms of network adapters, here, if it started from GNS3, okay, because it started from GNS3, it will display generic driver UDP tab. Okay, do not freak out when you see this. Usually it's bridged or not, or other configuration, but if you do like that, that's how it's displayed. And this should be, just 1 second, from preferences, if it loads. Okay, so here, okay, I have the router IO and switch IO, what I previously discussed, and the virtual machines. Okay, so if I integrate, let's say, this one, WordPress or Ubuntu, okay, I can start them and integrate it in the network. That's one thing. Second thing, in order to connect this typology to the that I'm using, also the one from the host, just 1 second. So just to show you the IP address, so this is the actual network adapter, okay, Ethernet, so Ethernet, and I have 192.168.0.100, and the gateway is 0.1. Okay, in order to integrate have connection between this route and this one. First, you need to choose in Geneset Ray another IO, which is in VMware Workstation Player on Windows. And here you need to specify on other adapters, not this one, the host only, which is this. So for, in this case, ETH2, it's the third because you have ETH, ETH1, and ETH2, ETH1 and ETH2, sorry. And this one, which is the third, you need to configure it and specify the NIC, so, or the network interface card. Okay, so basically this you need to specify such that you can have in the same. Another thing, you need to work on cable. So basically, I can show you this. I need a cable, okay, like this, between the router and the host. If you use the wireless adapter, it won't work. At least in these versions of Geneset, I have 2 something version. Now, all this said, I have .100, my host address. I configured all this in terms of command prompt. In SolarWinds, it's easier to pass between them, or if not, just open the console in PuTTY, okay, and so on. But it's easier for me to show. Now, accessing the configuration in terminal, I want to display show IP. So for interface E03, which is this one connected from ISP router to the cloud, connected to the host, this PC, it's having an IP address 192.168.0.102 using DHCP service, which is provided by the router that I basically showed you previously. Okay, so if I want to ping between ISP router and my host to see connectivity, 192.168.0.100, okay, here you see that I have connectivity. Now let's ping between 0.102 between the Windows and the ISP router. We have connectivity, okay, good. Now I will go into this typology, then into switching, and afterwards here and connecting through the internet. Okay, now the ISP router has .102 for this network, which is the network of the host, the LAN. Okay, now this network, as was presented in area 0, it's 89.61. I will zoom in a bit on different parts such that you can see better. 0.24, and I needed to use mask of 30. Mask of 30, 32, maximum size 32 minus 30, it's 2 to the second power 4. So we have 4 addresses minus 2, the first of the network and the last one of the broadcast. We have just 2 available IP addresses, which is basically very efficient in this case. So I started from here, .0, .4, .8, and so on and so forth. And I will open this and just display the routing table. So let's go for R1 such that I can show route. Okay, so R1 on interface gigabit 10 to this one, and it's this network, which is just a second 0. This one directly connected. Do show IP interface with. Here I see .1. Okay, the IP address. Now on R3, which it's the same gigabit Ethernet 1.0, but it's the interface of the R3 router. It's where it is. It should be that. Sorry, on R3. Configure terminal to show IP interface with. Yes, so on this one, on R3, again, it has .2, and so on and so forth. So I subnetted all this also for the serial interfaces, and I reach .28. So the last IP addresses are .29 and .30, the connection between R4 router and ISP. All these are in area 0 in OSPF protocol. Now, if we go back to this, so you see this one, okay? .0, .4, .8, .12, .16, 20, 24, 28, 28 also it's directly connected and also local, okay? So you see all these which are in area 0. Now we can go also in the running configuration just for want to see. So I included also this interface in no, I included, yes, I'm not mistaken, I included this network in area 0, and we'll discuss later about other areas. Now I will open another one, let's say R4, will show run, and for R4, okay, on gigabit 1.0 we have this, also the serial interface, and you see here I included in area 0, I included these two networks. We'll discuss later about this. Basically the IP of each router, except this one, it's 888.8. All the other routers have the ID from the number after R. So this is 1111, 3333, and so on and so forth. Okay, basically this is how I configured it. Now let's check some connectivity. So if I want to go from R1 to, let's say, R4, go ping 89 61.1.8, let's say .26 on this interface, on the S60 on that IP address. Okay, I have connectivity, and if I want to see the path, I trace route, do trace route 89.61.1.8.26. Okay. And it will display it needs some time, but it will display. So .2, so basically from R1 to R2. Now it will go to .18. .18 it's this one, so to R4, then to R5, sorry, then to R4. Okay, and it finished. This is how they connect. We can choose also, let's say, this one, R6, to pass to this, to see how it chooses, basically on that metric. Okay, so we have do place route, because it's Linux, 89.61.1.8.86. Okay, and let's see. .10. So from here it's R2, then 14 it's R5, then it will be R4. Okay, and if we check this IP log, okay, we have this place here, okay, because it's OSPF, it's 110, this metric, and it shows all the routes. Okay, so basically this is how I configured the routers with OSPF in area 0, how they obtain connectivity between themselves. We can assimilate this area 0 as internet because it is a public address. Okay, and this is how the routers communicate. Now, given this, we will pass into the second, to this part, the local area part, and let's go to not R1, R2. Let's show IP. Okay, so we have these networks. This is connected. This is connected 12 and 8 and also 20. We also know these ones, which are obtained from the neighbors using the OSPF protocol, and we see that we have OIA and OIA inter-area network, inter-area path. Now, actually we have this network, private one, 172 .26.62.0, and also another private one, 10.33.0.0. I have that one for this interface, the ISP, the IP address for this one, and .7, the IP address for this virtual PC. That one for this interface of the router, and .8 for this. Now, it's written here that we have this one, which is connected, but if we go to, let's say, router 3, we'll show the interface brief, we'll show IP route. We see this one, okay, this is of interest, this one, and it should be 10.35. Okay, so it's this one, and the next hop it's .18, so it will pass through this. Okay, and these are other networks from the switching part. Okay, I also added them as inter area from the switching part. And this one is 10, yes, this one 10.33.0.0, again through .18. Okay, so again to this one. So this is how I can connect from a local area into, let's say, internet. Okay, these areas. Now let's test this. Okay, go into PC. I think this is PC8 and this is PC7. Okay, PC8 SH. So we have this network .0. We have this IP. The mask is 24.255.255.255.0. 10.0, and this is the gateway, okay? And I want to, let's say, connect to this. So ping 89.61.1.8.26. Okay, I can, because I used OSPF in that area. How I did that? If I go to router 5, show run configuration. Okay, so area 4 was added here in this process in router OSPF 1 with this ID. All these networks are added for area 0, and this one was added for area 4. So this is basically how end devices can connect into this public area. Okay, here I did not have problems with translating the IP address. You will see here I will explain a bit what I did. Now, going into the left part, the switching part, and I will move myself here. Okay. But before that, the internet will be tested afterwards. Okay, so the switching part. So I needed to define these VLANs, okay? So for marketing, for sales, for manufacturing or production, finance, HR, and IT, okay? These are in the first part, like attributed, but were defined on all switches. So on switch number 3, for example, I defined all these 6 VLANs, okay? Not 40, sorry. Let's say this one. Will show VLAN, okay? I have all these 6 switches defined. Now, after defining the switches, the VLANs, I needed to define this and also these 3 routes or path as trunk, and this, and this as access. Basically, the trunk allows passing packets between VLANs. Okay, now, let's test connectivity between this PC and this PC, for example. Okay, so between PC3 and PC1. Show. So we have 10.30.0.254 mask 24. Gateway has .01. We will discuss a bit of router on a stick afterwards. So let's ping 10.30.0.1. Okay, so I have connectivity from here to here. Let's ping to PC number 10.20.0.254. I have connectivity, and let's exit into internet. So let's ping the ISP. Ping 89.61.1.8.30. I have connectivity. Okay. So I can reach between this area. I can reach this router. Let's try to reach. I can also reach the internet, this area, also the internet, you'll see afterwards. And let's say we want to reach also this area. I don't know, this PC. Okay. Ping and 50.0.254. Okay, available. Let's do it the reverse from this here to something and also here to something. So from 6, PC number 6, show, okay, ping 10.60.0.1. I can access router 6. Let's go to router 1, which is 189.168.5, I have on this interface this IP address, I ping it, and let's ping PC number 3, 0.25. Okay, I have connectivity. I will not repeat for each PC, you get the point, everything works here, and also I can connect to here and also to here. Now, I configured also here OSPF. 1 second, sorry. Do show run. And afterwards we'll discuss about router on stick. So for this router I used area 1, okay, and I included these 3 networks, and area 0 these 2 networks. Similarly it was for switch for router R6, included these 3 networks and also these 2. Now, in terms of connecting between these 2, I wanted to use, at least in this case, static routes, and I will show you immediately. Do show IP route. Okay, so you see with S differently from O or OIA, not inter area, because static routes override the dynamic routing protocols, OSPF in this case. So between router 1, okay, and router 6.5.6, I have this network 60, 50, and it should be 40, yes, this one, through 89.61.128.6. This the IP address of this interface perfectly, and you can see that it overrides and it uses this static route instead of OSPF protocol. Why? Because we have the metric of 1 here instead of 110, and here we have the number of jumps of hops between the addresses. So I have directly connected R1 with R6 such that this can be connected. Okay, so this is a use of static routes. Now, in terms of a router on a stick protocol, I configured virtual interfaces such that the VLANs can communicate. So in the case of R1, we have, 1 second here, okay. So for interface 0.0, but it's .100, and the activated encapsulation .1 Q, the name of the VLAN 100 for marketing. The IP address is this one, so always .1, the IP address of the router with the same mask, okay, .200 for the 200 VLAN, and so on and so forth. So for these 3, and you can see them in the routing table, which are these. Okay, so this is how I enabled router on a stick, basically configuring virtual interfaces such that routing is enabled, and this is enabled only here, okay, such that this PC can go to here, configuring also the links between the switches correctly as trunk and this access. And if I want to exit from this area to the second, I'm going through that static routes. Okay, so this is basically the main, these are okay, the requirements written, and these are again on short what was needed to solve the project. Okay, now let's go regarding the internet access, also the static default route, virtual machines, and how I can obtain access to them. Now, this was a bit trickier because if I wanted to ping where just whatever device, doesn't matter, PC3 or even this router or even this one, if I wanted to exit through the internet, I could not, except if I configured, on R4 a default route, and this is do show IP route. This is shown in this is the static route defined. So the IP route basically directs all the traffic to internet through this hop. Okay, so everything that wants to exit the internet, I'm telling it go to here, and this is directly connected to my host and to the gateway. Basically, we'll see how. Now, another key aspect was that through this, only R4 knows how to obtain access to internet, but if I am pinging from R3, it will not know. Okay, so in order to redistribute this static route to, let's say, R1, and you can see it, okay, it's here, O star E2, and if we go to the legend, okay, so these two, OSPF external type, sorry, so this one, okay, we see that this static route was redistributed through the OSPF protocol, okay, and it has one hop. Okay, now I am demonstrating that I can exit the internet from R4, from R1, and so on. There's 2, 3 links. So if I am pinging, ping, let's say the common Google server 8.8.8.8, it works, and I also configured IP domain lookup and the name server as the gateway 192.168.0.1, the physical router. You see that it solves also the DNS request. Okay, let's choose something that I have tried, Cisco.com. Okay, it works. Okay, so from here to here it works. Let's go to R6 here below. Okay, go ping Facebook. It works. So basically I can exit to the internet. Let's try from PC number 4. Okay, show ping 8.8.8. I have connectivity. Here it's a bit trickier because even with trace, you need to specify trace and this host and so on and so forth. But I have connectivity to the internet. Let's choose another one for the sake of the argument. Ping 8.8.8. Okay, so I can exit the internet. So everything here can exit through here. Okay, now on this router, in order to have this access, I needed to configure NAT. On short, network address translation, opted for path for sure. So for port address translation, basically it translates a IP address into other IP address from private into public usually, and it uses the ports. Okay, now if we go to how I configured it, on this interface E01 I have NAT inside, and on E03 I have NAT outside. Usually it's the other way around because you have inside local, inside global. These are public IPs, so you should have here out and here in. Okay, if I do that, I won't have connectivity to the internet. This is due to some sort of tricky configuration in GNS-array and routing, because if I'm configuring as I should be, here out, here in, this will not work. And I opted to do that even though I have no internet here, but to access the services that I wanted. This is a bit, let's say, not very common or common practice what I'm using, and that's why it's a bit tricky to see. Okay, so this was needed such that internet can be accessed from these virtual devices, okay, through this ISP router, through my cloud. Okay, now regarding these virtual machines, I already specified at the beginning the configuration in terms of network in VirtualBox, and if you include them, how are connected. Now let's see how I can obtain how I can access the service. And let's start with WordPress. I configured on the ISP router DHCP, so I have DHCP for this and also DHCP for this one, okay, with 85.4.4.0, router is .1, and whatever address it chooses, the WordPress machine it takes. And what I wanted to show you, okay, OSPF, here I included the area 5, but it's not that necessary to have that. Only if I wanted from a virtual PC to go to that. I tested also that, so that just quickly bring 85.4.4 and it's 2. I will show you immediately so I can go from here to here. Okay, now let's go back to ISP. Okay, also in NAT I needed to specify in terms of how I configured path an access list, one in which I permitted the trafficking between inside and outside, so from ISP to host and so on. Okay, the traffic is permitted to pass, and it was this line. It's the path configuration source, this one interface city hash Ethernet 03, which is this one over. Okay, and let's show it out. Here I have all the routes, even these ones. This is the static one obtained from the physical router. Okay, so it knows how to go internet. Also, here you see the gateway, which is correct, and you see basically the routes, inter-area routes, here from area 0, so on and so forth. Now, just picking from the other monitor, the WordPress machine, is this one. Okay, we have this IP address, 85.4.4.2. No, it's a public address. So if I am choosing, and I will go into a incognito such that I'm sure that it doesn't load from cookies or history, it works. Okay, and I can prove it that if I change a setup, it won't work, so it doesn't load from history. Okay, interface is 02. Now I've been outside, I've been inside, and if I restart this, you'll see that it won't work. It will load, but it won't work. Okay. Now I've been inside, I've been outside, and now it works. And let's go to this. Okay, it works now. Even if I want to access the login, it works. Okay, so I can access like that the service. Okay, but how did I access the service? Because this is the public IP. How does my router know how to do that? Well, I have two options and I tested both of them, and I will show you how I did that. You need to go to a administrator command prompt. Okay, I know the IP, and you need to specify in the routing table a static route to that network. So just, I've already done that. I will show just the comment. I specified this network 85.4.4.0 with this mask through 192.168.0.102, which is the IP address of the ISP router. So that's why if I am if I'm tracing the path to that virtual machine, it won't go into internet. Otherwise, it will go outside into internet. You see that it went into my basically my ISP router and then to this machine. Even if I do the reverse, okay, trace route 192.168.0.102. Okay, just to prove it. Sorry, .100. It should pass through .100. It should pass through this. .100. Perfect. I don't know why it's blocked. It should be .102 and that 100. Okay, so this was a bit tricky. Second option was in the configuration of the network adapter to go to properties, IPv4, and here specify statically an address, the mask, and the gateway basically the ISP, and I've also done that. So 192.168.0.102 in this case, and also the DNS I tried with 102 and also with .1, the physical router. Sometimes it works best with the physical router. And if you do that, basically the ISP router, it's my router. So I'm basically taking all the internet traffic, not from the physical router, but passing from the physical router to the topology. And if I want to access whatever service, YouTube, sports, whatever, searching on internet, I'm taking traffic from the ISP router, which is crazy. So virtual router, okay. That actually works like a physical router. That's what I wanted to say. So you can do also that. Sometimes it's not the best, because even here when you configure not inside outside, you can have some problems. Okay, and just to check, to show IP not translation. Okay, we have it shows basically. So from 102 on this port to 100 on this port, that inside local and global, local inside global, and the outside local and global here. Okay, that's why I've written here, even though it should be differently, not outside, and this is how communicates, and this is how I can access from my host this service. Okay, as it should be in exterior in internet. And I've done that also using a local address on Ubuntu. I wanted to check just for a simple service. Okay, 192.168.192.168.5.2. Okay, it works. Just prove it because I have the Apache server service Apache stop. Okay, and I'm stopping Apache 2.7, and I have a simple page loaded from just 1 second. Something here I loaded. It's not that one. Okay, so look, I stopped the Apache server. This doesn't work, which proves my point. I go back here. Sorry, here. This service Apache start. Then this should work, okay? Yes. Of course it doesn't. And now it works, okay? You see it works. Okay, just some basic HTML page. Okay, and so it was a basic HTML page, so I exited the button. I just wanted to show you that even though I do not have internet, what I can access through the LAN, if it allows me, okay, Firefox, perfect. I wanted to show you that I can access that this server, okay? So this can be accessed. Let's see. Click this, it works, okay? So basically, this is how you integrate this. Just 1 second. I added also that network. I added, yes. Okay, so through that router, you see that it has similar metric thing being a static route, and the command it's like this: route add network mask 0 and the gateway, something like that. Okay, if you want to delete, you delete like this. If you want to change. So it's basically very simple. Okay, you can also delete the static default route, and make sure that you pass all the traffic to the 102, but sometimes it has some problems, so I played a lot with this configuration. Okay, so basically this is the project. I think I described everything that I've done. I did not go very into details in terms of configuration, because I used the typical configuration from Cisco, and I think this was much more interesting, and to check the connectivity between these machines. Okay, let's check also from Ubuntu. So you see that I can access also the host 102, it's the ISP, even if I access the service. I just wanted to prove the point. So I consider all the tasks solved. Now let's go back to conclusions. Okay. Second. So in my opinion, it was a very appropriate project that tested the knowledge that I gained. I think it's very useful, such that you pass through such kind of tasks, you understand how to connect virtually in Genesis Tray router, how to connect to internet, so on and so forth, how to have a local network and everything to work. Also, yes, it was challenging to have it in a complex way such that you can emulate switching, you can also connect to internet and have all this. Yes, it was a bit challenging, I won't neglect that. So I addressed the following concepts: IP addresses, subnetting, even, okay, we did not go into very complex typology, but one may understand with a very good level how to subnet basically and to allocate addresses dynamically, statically, so on and so forth. We went into static routes, dynamic routing protocol, OSPF. Okay, I use that because it's vendor independent, not like the IEGRP from Cisco. DNS server for that name server, such that it can solve even for routers and from PCs in the Genesis 3 typology. Also DHCP server, such that service such that it can allocate dynamically IP addresses, such that we do not do it manually. VLANs and switching, also router on a stick, and connecting the typology in the same network as with the host and accessing the internet, also integrating some virtual machines in the typology and accessing the services on that. Basically, I consider that in order to be proficient in cybersecurity, you need to allocate some time on the networking, computer networking part, develop knowledge, apply them, understand, and it will help you a lot in your career. Thank you very much. It was a very nice project. I'm looking forward to other projects. Please comment, like, subscribe if you want, and let me know. Give me a feedback on how it went. Thank you, and see you next time.